Hey guys, this is Mr. Beckstrom, and today I want to take a look at an example from section 6C. This is on the normal distribution that we talked about in class on Wednesday, and it says, assume that the resting heart rates for a sample of individuals are normally distributed with a mean of 70 and a standard deviation of 15. Use the 68, 95, 99.7 rule to find the following quantities. All right. So what does this rule mean? That means that if we have a distribution, which is a set of data values that follows a normal distribution, and as we said before, following a normal distribution means that we have this bell curve. That means that uh, in the lower values, the frequency starts off low, which means like if we're talking about men's height, we don't have a lot of men that are like 4 feet tall or 4'3". And then as we get to around 5'5", 5'6", we have a lot of men that are in that category. But then as we get around to 6'5" and 7 feet tall, once again, we have a low amount of men in that category. So we kind of go low, high, and then low. So men's heights are one of those distributions or set of data values that follows a normal distribution. So it also follows, since it follows a normal distribution, it follows what's called a 68, 95, 99.7 rule. And what that means is that if we find that standard deviation, which is that kind of that average value that the data uh, falls from the mean of that data set, then what we can do is we know some information about it. We know that roughly 68% or a little bit more than 2/3 of that data falls within one standard deviation of the mean, of the average. So, almost 2/3 of that data is real close to that mean, right? So let's say, for example, the average male is 5'9", and there's a standard deviation of 3 inches. That would mean that 2/3, or a little bit more than 2/3, that every 2 out of 3 men are somewhere between 5'6" and 6'1". That's what that means. They would fall within 3 inches of 5'9". Actually, I guess that would be 6 foot, right? 5'6" and 6 foot, right? So, and that's what that would mean. And it would mean that 95% of men would fall within 2 standard deviations. That means if you subtracted 3 inches again, another standard deviation, that 19 out of every 20 men would fall within that range. So subtracted another 3 inches from both sides. If you went from 5 foot, you went 5'6" before. If you went from 5'3" to 6'3", that almost all, 95%, 19 out of every 20 men would fall within that range. And then if you went another standard deviation beyond that, if we went to 5 foot to 6'6", that 99.7, almost the entire population of men, would fall within that range of this distribution here. So that's what it's saying. And this follows every normal distribution that's out there, and there are literally tens, if not hundreds of thousands of distributions out there that follow this normal distribution. So how can we use this to answer questions? Well, we need a mean and we need a standard deviation, and then we can answer these questions. So I broke this down, and since the normal distribution is symmetric, I even broke it down into halves. So since one standard deviation is 68%, if you look at each half, that would be 34% on each half. Just 68% divided by 2 is 34%. And then if you looked within 2 standard deviations is 95%. Well, one is 68%. So if you did, let's look at it this way. If you did 95% minus the 68% that we already used, we have 27% left. And these two sections here are the same. So we divide those by 2. And that's how we get our 13.5% for both of those. And then, so the 99.7, so you do the same thing, 99.7% for 3 standard deviations. You subtract the 95% that we've already used from the 2. We're left with 4.7 left, and we divide that by 2 in order to get the 2.35% for these last 2 sections. And then the remaining from 99.7% and 100% is just 0.3. And half of that for each one of these remaining tails would be 0.15 because the entire amount has to be 100%. All right. So this means that if we are given a mean and a standard deviation, we can answer a bunch of questions. And all we're doing is just adding these sections up to answer the questions. All right, so this next one says, or let's kind of go through this. This has a mean of 70. So what we're going to do is we're going to put the mean right here. I'm just going to kind of put it right where it is, so right in the middle. So the mean goes here, and this has a standard deviation of 15. So that means each standard deviation we go out 15 units, right? So if we go 15 units, one standard deviation, we just add 15. So that's 85 is for 1. If we go out another one, we add another 15. So that would be 90. Oh, not 90. That would be 100. Can't add today. And if we went another one, that would be 115. All right. And if we started subtracting standard deviations, which are 15, so 70 minus 15 is 55, minus another 15 would be 40, and minus another 15 would be 25. All right. And here's the percentages, and if we want to, they're actually asking for the relative frequency, so that's just the percentage in decimal form. So we can calculate the percentage, and then we'll just convert it to a decimal as our final answer by moving the decimal place to the left. All right, so the first one is, and let me have my calculator out here, is the relative frequency of less than 100. So here's 100. So I want everything less than it, right? So it's going to add up all of these sections here. Or if I know that the whole thing adds up to 100, I could just do 100 minus the 2 sessions that I am not using. So I can just do 100 minus these, right? 2.35 minus 0.15. So this one is 97.5%. 97.5%. But once again, they asked for it as a relative frequency, so I'll convert that to a decimal by moving the decimal place to the left. So the answer would be 0.975 for the first one. Or you could have just added up, here's 100, and it's asking for everything less than it, so you could have added up all of these percentages here, and you would have gotten the same thing, 97.5. The next one says the relative frequency of rates greater than 85. So here's 85, so we add up these 3 there. So let's just add up those 3. So 13.5 plus 2.35 plus 0.15, and I get 16, so that would be 16%. So that's the percentage of finding a value that's 85 or greater, which converts to 0.16 as a relative frequency. And the last one says between 40 and 70. Here's 40, there's 70, so it's just 13.5 and 34. So just add those two up. 13.5 plus 34. And that is 47.5%. So this is 47.5%. And converted to a relative frequency would be 0.475. That's it, guys. If you all have any questions, please let me know. And I hope you have a great rest of your week. Thanks.